Okay, so on this paper of our theorems, we're going to cross out, it's not a mini quiz, it's just the theorems. At the top of your paper, I want you to write the word if in pencil. And I want you to write the word then in your red pen. I wish I could use red, but when I put then up here in red, it kind of looks the same. So I'm going to be using blue, so it's easy for you to see from where you're sitting. So what we're going to do on this paper and for part of your quiz Friday is we're going to write the if, and we're going to draw the if in pencil. Then we're going to draw the then and write the then in pen. Let's get started. Number one, with your pencil, if you have a radius, draw a radius in your picture. There are an infinite number of radii. That's a radius. That's a radius. Pick your favorite radius and draw one radius in your picture. A radius goes from the center of the circle to the outside. Let me keep reading the theorem. If you have a radius and a tangent, I'm going to draw some tangents. I don't want you to draw this tangent. A tangent is a line that touches the circle one time. Don't draw that. This is a different tangent, touches once. Do any of those tangents touch my radius? That's why I don't want you to draw those. We have to draw a radius and a tangent that meet. The point they meet is called the point of tangency. So I want you to draw a tangent line that touches your radius. This is the only tangent line that touches the radius. So let me read the if one more time. If you have a radius, got it, and a tangent, got it, that meet at the point of tangency. This is where they meet. It's called the point of tangency. Go ahead and set your pencil down, grab your pen. Then, who can remember the then part, or you can look it up in your notes that you have in front of you. This was the first day of notes. It's probably the first box on your notes from Thursday. Yes. So write in your pen, then they are perpendicular. And draw they are perpendicular in your picture. That's an easy one to draw. Perpendicular, 90 degrees. This leads to some Pythagorean theorem questions because we have a right angle. You don't need to draw this part, but this is why we sometimes have Pythagorean theorem, because they are perpendicular, which creates right triangles. All right, number two, grab your pencil. Let's do the if part. Number two, if a circle has two tangents that meet at a common external point. Let's draw an external point, a point outside your circle, anywhere you want. Now you need to draw a tangent line, a line that touches the circle one time. That's just one tangent line. Now draw a second tangent line. It's okay if it goes past there, but I usually just stop at that point. I believe we're done with the if. Let me read it one more time. If a circle has two tangents, that one has two tangents, that meet at a common external point. Your paper look good? All right, set your pencil down, grab your pen. Then, who's got this one? What happens if I have that? Look at your notes, probably the second box. Very good. Then they are congruent. How do we draw congruent? Congruent means they're the same length or equal. So we show that this, whatever number it is equal to that one. Don't make up a number. I think you guys are getting the hang of it. So this is what I mean by Friday, you're going to have a red pen because there are going to be about 5 of these. where I will give you, you won't start from scratch. I will give you either the if in words or the then, and you will fill out the other part. And the picture, you'll have to do both the pencil and the red pen part. All right, let's look at number 3. If you have a diameter, let's draw that. Diameter. The cord that goes through the center. Do we know there's an infinite number of diameters? I don't care where you draw your diameter. This is a diameter. This is a diameter. Pick a diameter and draw one of them. If you have a diameter and a perpendicular chord, let me show you some options. Here's a chord that's perpendicular. Here's a chord that's perpendicular. Here's a chord that's perpendicular. Draw any chord you want that is perpendicular to the chord you already have. Now off to the side, I'm going to make a list of 3 things. These are on your notes. You don't have to write them. Diameter, perpendicular chord, bisected chord. I think this was Friday's lesson. Anyway, it was 24-2. We talked about a theorem I call 2 of 3. The 2 of 3 theorem says, if you have 2 things on this list, you actually have the third. If you have any 2 of those on the list, you have the third. Let's take a look. We have a diameter. We have a perpendicular chord. Therefore, with my pen, I'm going to say, then I must have bisected chords. Then chords are bisected. Maybe not chords. A chord is bisected, I might say. Then a chord is bisected. Sorry, both chords aren't bisected. One chord is bisected. Here's how you can tell which chord. It's not going to be the diameter because look at where they touch. Do you see how this chord was not cut into 2 equal parts? So both chords are not bisected. It's this chord that's bisected. That's not how we draw bisected. We show that they are equal length. So go ahead with your pen. Because we had 2 things on the list. The third is we have a bisected chord. I'm not super picky on your wording here. You have to have the word bisected for sure, but don't be too worried about how you phrase it.
If it was in the middle, would it be both of them were bisected?
Then it would be yes. Yep. All right, number 4. Let's start drawing in pencil. If you, I left a word out. If you have a chord that is a perpendicular bisector of another chord. So this time I have perpendicular and bisector. Perpendicular and bisector. I'm going to draw those first. So draw any chord you want. Maybe we'll start with a chord that looks like this. Now you have to draw a chord that cuts that in half. And where it cuts in half, it's perpendicular. It's really only one way to do that. If this is the middle, there's perpendicular. And this is bisected. If you have a chord that is a perpendicular bisector of another chord, perpendicular bisector, then I've got this third thing. Then one chord is a diameter. Again, I'll be lenient on your phrasing. You have to have the word diameter, but how you describe it, I might be okay with a different way to describe it. Do we know how to draw diameter? All you gotta do, show that it goes through the center. All right, you try number 5. I believe it's still 2 of 3. You're just pairing 2 different things together. Give 5 a try. Yeah. So you'll have a blank circle. And you'll either have the if words or the then. All right, number 5. If you have a diameter, chord that goes through the center, and a chord that is bisected. So you need a chord that's cut into 2. Oh, I will be looking on a quiz for that. Did you draw the diameter to go through the center? Did you draw a chord that's bisected, cut into 2? If you have those 2 things, then you know this third thing. Chords are perpendicular. And you draw, perpendicular. All right, number 6. If 2 chords are equal distant to the center, let's start by drawing the center. If 2 chords are equal distant, I know it says equidistant, that means equal distant. Draw any chord you want, not a diameter. Pick a chord, any chord. Now, if I asked you to come up and measure the distance from the chord you picked to the center, some of you may place your ruler right here and say, 2.7 centimeters. Somebody says, no, the distance is this, 2.6 centimeters. Somebody might say this. There's a bunch of ways that you can measure how far it is from the center to the chord. Does anybody remember from the video or the 24-2 lesson how to correctly measure so we all get the right answer? Very good. Straight, which is going to be the shortest, and also perpendicular. Go ahead and draw in the shortest distance possible, which will always be the perpendicular distance. Our picture currently has 1 chord, and we've measured the distance to the center, or we've shown the distance even though we didn't measure it yet. We need to have 2 chords. So draw another chord that you think has about the same distance to the center. Show that when you measure the distance, it's going to be the perpendicular distance. Let's see if we're done with the if part. If 2 chords are equal distant to the center, You think we're good? We're close. Does my picture say that this distance is the same length as this one? Don't I have to do this to show same length? Forget that. To be equal distant, you have to show the little slash marks. Now we're done with the if. If I have two chords that are equal distant to the center, then the chords are congruent. We know how to draw chords are congruent. This chord is equal to this chord. I put a double mark because I've already used a single mark. I try to make it large. I don't want people to think that this little piece equals that little piece. And that's why I highlight the whole thing and kind of make it large. Hopefully Friday when we're taking the quiz, as you draw the if, it reminds you of the then. So there's a little practice outside of class, a little memorizing, but once you draw two chords equal distant to the center, you might be kind of already set up to remember the then part. Number 7, if two chords intersect in a circle, draw any two chords you want. They have to touch somewhere. They don't need to be perpendicular. They don't need to go through the middle. That's the if part. You're done. If two chords intersect in a circle. I got two chords and they touch. Pick one chord, either one you want, and label one of the little parts A and the other part B. I guess you can read that A and B. Take the other chord and call one part C and the other part D. Below the picture, write this. A times B equals C times D. This does not say that if this chord is 10, this chord is 10. That's not how it works. It's the parts of the chord multiplied together. The two parts of this chord multiplied together equal the two parts of the other chord multiplied together. Let's go ahead and write that. So then, it's going to be a little wordy. Then, two parts of one chord multiplied together. Two parts of one chord multiplied together. Equals, you can probably guess, what does that equal? It equals two parts of the other chord multiplied together. All right, we have to add one more on the back. I don't think there's room at the bottom. Theorem number 8. If a quadrilateral is if a quadrilateral is a four-sided figure, is inscribed in a circle, we'll draw that. The easiest way to draw a quadrilateral in a circle is not just to do this. That's not how it works. It's got to be touching the outside of the circle. So I like to just draw 4 dots on this circle. Anywhere you want on your circle, draw 4 points anywhere you want. And connect one to the next. That is what you call an inscribed polygon. Specifically, this polygon has 4 sides, so it's called a quadrilateral. Polygon is just a figure with many sides. By the way, the circle is called a circumscribed circle. If you hear that vocabulary, the circle is referred to as a circumscribed circle. The polygon is called an inscribed polygon. Does anybody remember, or you can see it right in front of you, what happens if I have a quadrilateral inscribed in a circle? Kaylin, I saw you look. Did you find it?
Yeah, the opposite angles both sides.
Good job. Then opposite angles are supplementary. I'm hoping everybody in here remembers what supplementary is. Tyler, what is it?
180 degrees.
Very good. 2 angles that add to 180. So here's how I draw opposite angles supplementary. I pick any angle, I'll call it A. And I'm going to pick the opposite one, so not next to. I'm going to call it C. You can call it whatever you want. Pick 2 angles that are opposite. And show that they're supplementary. So I would say measure of angle A plus measure of angle C equals 180. I know this is a lot, but the more we do it, this is the second time now that you've written them. You'll write them again before the quiz Friday. You'll look over them, you'll use them, and hopefully you won't have to memorize too much. You'll just kind of know when you see the if part, you'll kind of know what goes with it. Any questions on any one of these theorems? Okay, we have 2 homework assignments to go over. Let's look at the first one. 24-1, 24-3, that was from Thursday. I don't expect you to read the answers from the board, so I will read them aloud. You can correct it with your pen. 1E, 2G, 3D, 4B, 5A, 6C, 7H, 8F. Let's talk about secant, because we haven't done secant yet today. Secant, remember, is a line that touches the circle 2 times, whereas a tangent touches 1 time.
What was one again?
One is E. Wait, center. D, where's D? Point of tangency. E, yeah. All right, so besides this vocabulary, every question from here on out goes with a theorem. Especially 9. Let's take a look. Number 9, draw a radius and a tangent that intersect. Draw what happens when a radius and a tangent line meet at the point of tangency. That's that first theorem we just went over. You write it and you draw that they are perpendicular. 10 through 12. In the diagram, BC is a radius of circle C. Determine whether AB is tangent to circle C. Explain. Let me go to this theorem here. It says that we have a radius. The directions say you have a radius. So yes, we know that for sure. It says, is it tangent question mark? Here's how you determine if it is. If they form a right angle perpendicular, then yes, it's got to be tangent. If they are perpendicular 90 degrees, then of course you have a tangent. So let's take a look and see. Number 10. I know this is a radius, and I see that they are perpendicular. So absolutely, yes, that is a tangent because they're perpendicular. $11. I don't see a right angle symbol, so I don't know. It looks 90, but so does 12, and 12 is actually no. We learned back in activity 20 how to take three numbers and determine if it's a right angle or not. So I take 3 squared plus 4 squared, and I compare that to 5 squared. And I figure out that it actually does form a right triangle. So if I have a right angle, I definitely have a radius, and 4, yes, has to be tangent. Same idea for 12. Do the numbers 3, 6, 7 form a right triangle? When I do it, they are not equal. So this is not a right angle. So no, 6 is not tangent. Have to have some work there to get a 10 out of 10. 13, I mentioned in the lesson that this takes a little bit of work. We do the Pythagorean theorem, but what's different about the Pythagorean theorem is not the beginning. R squared is pretty typical. 12 squared is this. The interesting part is the hypotenuse. If you take a look, the hypotenuse has 2 parts, R and 8. If it has 2 parts, not just one number, you have to make sure to write it R plus 8 or whatever it is added together. Now, in the video, I said you will not distribute. That is not how algebra works. Heard it. You will not distribute. Squared means times itself. So R plus 8 squared looks like that. Yeah.
Is that only when there's a variable in the parentheses?
Yes.
Okay.
12 squared is 144. So to do this correctly, you write it times itself. Now we're ready to distribute like normal. No change over here. R squared, 8R, 8R, 64. We know that 8R and 8R is 16R. Since they have R squares on both sides, I'm going to move them to be together. I'm going to move this R squared over, and this will almost always happen. It looks complicated with R squareds, but 1 minus 1 goes away. 1 minus 1 goes away. And what's left is a pretty easy algebra problem for you guys. You just have to subtract 64, divide by 16. Get an answer of 5. There will be one of these on the quiz. There's another one on the homework. It's a word problem. It probably won't be a word problem on the quiz. All right, on the back, we are dealing with problems that go with this theorem. We have a common external point, so these parts are congruent or equal measures. So it's really easy to set this up. This equals this. You set them equal, you solve, you get 2. These are tangents that meet at this common external point. They're equal. Set them equal, solve, you get 6. 16 is tricky. Same idea. You set them equal. But what happens with this one is you get an x squared that does not go away. If that happens, you have to factor. If your x squared doesn't go away, you end up having to factor. You'll get 1 for an answer. We're not going to go over factoring today. But I can go over that with you individually if you want to review on that. 17 is a lot like that tricky number 13 we did. You have r squared plus 45.3 squared plus your hypotenuse is r plus 38 squared. You write it twice, distribute it out, you end up getting 8. I really don't like the way A is worded, so I'm going to kind of skip over A. As long as you can find the R value, we're good. 18. You want to start by labeling, very important. So we have a bunch of tangents. We should not be doing the Pythagorean theorem. There are no right triangles here. So just want to make that clear. Here's what we have. We have, this is 15, this is 13, and this is 9. We'll take a look at your common tangents. Here's a common tangent here. So if this is 9, this is 9. If this whole thing is 15, 15 minus 9, this part has to be 6. Hey, look, I got another common tangent with this external point there, 6. Up here, 13 minus 9 is 4. So this is 4. Means that this external point, so this tangent is 4. Final answer, they want this number 10. All your work is pretty much done by labeling the picture. Questions? All right, put your score at the top so you don't forget it, because we're going to go over the other homework and then I will take your scores. That homework was significantly longer and more difficult than this next one. This is homework 24-2, and the first 3 problems deal with this theorem. 2 chords meet in a circle, then the product of one chord multiplied together equals the product of the other chord multiplied together. So again, you might not be able to see it from where you're sitting, but you can look at your paper. Here's one chord, x and 12 will get multiplied together. Here's the other chord, 20 and 3 will get multiplied together. Then you just do your algebra. 12x equals 60, divide by 12. 2 parts of one chord. Doesn't matter which chord you start with. I have 17 and 12. It doesn't matter which of those numbers I put first, as long as I don't put 17 with the x. Take one straight line, which is 17 and 12. The other straight line or chord is x and x. We know x times x is x squared. Square root both sides, 14.28. Be careful with 3. We did one like this in the lesson. Here I have 5 and x minus 1. You must use parentheses if there's a plus or minus. I don't just want to multiply the 5 by the x. It's the 5 times the x minus 1. So you have to put it in parentheses. Same goes for this one. 4 times x plus 3. You distribute the 5, distribute the 4, and finish solving. You get 17. All right, I'm going to make my list of 3 things here to do number 4. Number 4. Is AC a diameter? Explain. Well, let's see. If it is both of these things, then absolutely it's the third thing, diameter. Let's take a look. In this picture, I have bisected. I can tell by that drawing there. It's bisected, so I've got that. It doesn't say it's perpendicular, or else I would see a right angle symbol. So is one thing on the list enough to prove this? No. My answer is no. There must be an explanation. No. I put it's only a bisected chord. It would also have to be perpendicular. Let's look at number 5. I'm guessing a handful of you just set them equal because you weren't sure what to do. Here's how you know they're equal. I have a diameter. I can see it goes through the center. I have perpendicular chords. I see 90 degrees. Therefore, because I have 2 things on the list, I definitely have a chord that's bisected, cut into 2. So those are equal. 6 is a trick question. I wanted to see how many people would set them equal like they did in 5. There is no way to find x. It's not 4. There is no way to find x. We can't just get in the habit of setting things equal just because it worked for number 5. It worked in 5 because I had a diameter and a perpendicular chord. Therefore, definitely the chords are cut into 2. For number 6, I have a diameter. I can see it goes through the center. I don't have anything else. So I have no way to say it's cut into 2. So the answer is not possible. And I explain why.